Hey guys, welcome to day 11. Today we're going to do modeling one-step equations, and what this means is we're going to be writing equations from a situation or from a statement or from a text. So the first thing you need to know is obviously the definition of an equation. An equation states that two things are equal. So we have a left side is equal, so this left side is equal to the right side, right? So when you're constructing an equation, when you have a left side, usually what we have here on this side is we're going to go ahead and write this down. This here is our expression. And an expression is either a multiplication, addition, division, subtraction statement. So it's when you're adding something. And then over here on the other side, you have your total. Okay? Now, so you have your expression, and then you have your total. Okay, so the left side has to be equal to the right side. So usually when we do an equation, we always want to identify what is the total, right? So that's one of the first things we always do. We always want to know, well, what's the total? What's the given value that's given to me? And then the expression is constructed by the keywords that are given to you, which is why I have the operation keywords. If you recall, we had the anchor charts in our classroom where we had addition, subtraction, division, and multiplication keywords. We're going to go ahead and construct our own anchor chart. So I'm going to go ahead and put this is for addition, and let's try to think about different words that could represent a different operation, right? So some keywords that represent addition, I'm only going to mention some, I'm not going to mention all, okay? And I encourage you that as you are doing some practice problems, that you start adding into your anchor chart. Okay, so let's go take a look at addition. One of the most famous ones for addition is the word sum. Another one that we have is in all. We might also see together. Another one might be combined. Okay, so these are just words that when you see them, they represent addition. Okay, these are just some, by the way. These are not every single one of them. Another one you might see is all together. Okay, and it just depends on your situation. Now let's take a look at subtraction. You might see the word difference. Another word could be take away. Fewer. How many more? Another one could be less than. And remember, these are just some, they're not all. Okay? And as you are doing your word problems, you can also add some of your own. For multiplication, we have times. You might see the word each is a very famous one. They use that one a lot. You might see times as many. The word product. The word per is another very famous one. You might also see the word twice as, sometimes 3 times as. So that's what we also put times as over here. Okay, these are only some multiplication. Now let's look at division. For some division ones, we have the words, you might see half, split, evenly. So remember, division is every single thing gets an equal amount. You might also see the word the same. You might see the word shared equally. These are just ways that we represent. Distribute is a good one as well. Another one could be the word quotient. Quotient is the answer to a division sentence. Okay, you might see the dividend or the divisor. These are just different words to represent division. And as you are doing some examples, you can go ahead and do your own and just keep adding to your anchor chart. Okay, now these are just some, like I mentioned to you. Go ahead and pause the video and finish writing off your operation keywords. we're going to go ahead and take a look at 2 example problems today, and I'm going to go ahead and instruct you exactly how to follow along so that you can write your equation. So let's take a look at question 1. We have Anna wants to celebrate her birthday by eating pizza with her friends. For $42.50 total, they can buy P boxes of pizza, and each box of pizza costs $8.50. Select the equation that matches the situation. So first of all, when you're looking at a word problem, when you're looking at text, if you read it just automatically, just off the way that we just did right now, it's a little hard for you to kind of start dissecting in your mind exactly what has to be done. Let's take a look at what exactly it's asking me for. So it's asking me to build an equation. So knowing that knowledge that it wants an equation, we can automatically say, hey, I know that an equation is 2 things that are equal to each other. So I know that I can set up my expression equal to my total. And let's just go ahead and start inserting things into our structure so that we can start building the equation. So automatically, I notice something very important. I notice that the total is $42.50. How do I know that? It says it right here. So therefore, I'm going to go ahead and place that on the right side at $42.50. Then it says they can buy P boxes of pizza. I notice that it's also given me a variable. So this is P boxes of pizza. And I'm going to go ahead and write this down here. P represents boxes of pizza. P represents boxes of pizza. Now that we know that, let's go ahead and take a look at something else that it's giving me. I also know that each box cost $8.50. So that means that 1 box of pizza is equal to $8.50. So knowing that, if for $42.50 total, they can buy pizzas, technically what the equation is wanting me to know is, well, how many pizzas can be purchased, right? And just by knowing that simple fact, naturally in your mind, what you naturally want to calculate is, well, let me just take $42.50 and divide it by $8.50. So what you're saying is, well, let me just do this then. Let me just take that and divide it by $8.50, and that would just give me the number of pizzas, right? And a lot of us were struggling with that during class time. So now that we have that, we know that this would give you the number of pizzas. And luckily, we also know that P is the boxes of pizzas, or the number of pizzas. So then this is the variable P. So that will give us the solution to the variable. Well, think about it. This is what to do to solve to get P, the amount of pizzas. Well, think about what has to go on the left side though. Remember that the left side has to be the expression. So you're doing something to the left side. Think about opposites. If you're dividing something, I'm dividing here. What did I have to have on the left side in order to divide by 8.50? What's the inverse of division? Multiplication. So I'm going to go ahead and say, well, I'm multiplying it by 8.50. And by what? By P. Right? Now think about it this way as well. There is an operation keyword here that automatically should have told you, hey, that's going to be multiplication. And if you look, the multiplication keyword is each. So I'm going to go ahead and put that over here. That my operation keyword here was each, and each represents multiplication. Now that we have that, technically if you look at this, how did I get to divide by 8.50? Well, I obviously want to get P by itself, but I'm being multiplied, so I divide both sides by 8.50, which is how I ended up dividing over here on this side. I'm left with this. The left side now remains with P, and then whatever 42.50 divided by 8.50 is what the end my solution would be. So now, let's take a look at the equation that matches the situation. Is it the first option? 42.5 divided by 8.5 is equal to P. Let's take a look at what we did. Well, technically, yes, because if you look at it, that's exactly what we did on this side here to get to P, to give you what P is equal to. Now, what they're doing here is they're taking the total and they're dividing it by the cost of 1 to get the number of pizzas, which is exactly what we did in the equation that we constructed. Let's take a look at the second one. It says P is equal to, so the number of pizzas that you can buy is equal to 8.5. So you take 8.5, the cost of one, and you multiply by 42.5, the total. Can you imagine how many pizzas that's going to give you? That doesn't make sense to take the total and multiply by the cost of one. So incorrect. Then it says, the third one says 42.5 times P. So you're taking the total, you're multiplying it by the number of pizzas, and that should equal 8.5, which is the cost of one. Automatically, something I notice here is that this here is a total, and it's in the wrong side. The total should actually be over here. So this equation is not constructed correctly. The only correct option is the first one. So I'm going to go ahead and highlight that. This is our answer here. And we were able to figure that answer out by building our equation structure. Let's take a look at the second one. Mr. Herman's class is selling candy for a school fundraiser. The class has a goal of raising $500 by selling C boxes of candy. For every box they sell, they make $2.75. Write an equation that the students could solve to figure out how many boxes of candy they need to sell. First of all, they're asking me for an equation. I'm going to build my equation structure. Got the left side equal to the right side. I know that the right side has my total. So then I ask myself, is there a total? Even though it doesn't say specifically the total is this, it's telling you that their goal is to raise $500. So if their goal is this much, then this is their total. So I'm going to go ahead and insert that into my total section, just right there. And then it also says by selling C boxes of candy. So it's also giving you the variable, which is very important to annotate. So I'm going to put, okay, I know that C is equal to boxes. Let me erase that real quick. Boxes of candy. I also know one more thing. It says every box they sell, they make $2.75. So basically what they're telling me is that one box is equal to 2.75. Well, think about it. Naturally, what we want to do is take the goal and say, hey, well, let me just divide that by 2.75. And then when I do that, that's going to tell me how many boxes of candy I need to sell to reach my goal. So this will tell me the number of candy boxes. Well, we know that that is represented by the variable C. Okay, now, well, let's do the opposite of that. If you're dividing by 2.75 to get back to C, what do I have to have over here? The inverse of division, multiplication. So then therefore, I'm taking 2.75 and multiplying it by, you're trying to leave C by itself, the number of boxes of candy, by C. And if you were to now try to solve this, this is why we end up with this, because we have 2.75 times C. You want to get C by itself. How do we do that? Do the opposite of multiplication, division by 2.75 to both sides, which is exactly what we did. This would end up with C. And the way that we get that is by just simply dividing 500 divided by 2.75, which is what we had above. Now, since we're multiplying here, think about the operation keyword that we had here. In this case, one of the keywords that we see is for every box. So let me go ahead and write that down. My operation keyword in this case was every. And if you notice, we didn't have that one in our anchor chart. So I'm going to go ahead and add it here. Let's go ahead and put every. And so now the equation that you would use to construct it, or to find out how many boxes they used to sell, would be just the one that we came up with above over here, which is 2.75. Multiply that by the candy boxes, has to equal $500. This is my equation right here, once I followed the structure of building an equation. Okay, that is all for today. Today your assignments are you are going to do one with writing equations, and the second assignment is writing equations and solving them as well. So have a great day. Go ahead and send me a picture of your notes, and I will be checking your assignments today once you complete them.